Here in this video, we are solving two AIPMT questions. I will start with this first one, which says a circuit contains an ammeter, a battery of 30 volts and a resistance of 40.8 ohms, all connected in series. Right. So, I can draw them in series, but let me just read this sentence. If the ammeter has a coil of resistance 480 ohms. So, if I have to draw that as a circuit, I have to draw like this. There is a circuit with a battery of 30 volts. It contains a resistance 40.8 ohms. Yeah, all in series, that is why I am drawing them in series, and an ammeter. He is saying this ammeter has a resistance of 480 ohms. So, if required, in the place of ammeter, I can just draw a resistance of 480 ohms, because we are just talking about resistances. Look at the next part of the problem. And a shunt of 20 ohms. Shunt means a small resistance connected in parallel across ammeter. This is ammeter. So, in parallel to that, a 20 ohms is connected and everything is connected this way. If that is the case, what is the reading of the ammeter? That means how much current passes through this 480 ohms, that is the question, right. So, what we can say? This 480 ohms and 20 ohms are obviously in parallel. So, the effective resistance of as 480 ohms is parallel to 20 ohms. Their effective resistance is 480 into 20 by 480 plus 20, that is 480 into 20 by 500. These two zeros and these two can be cancelled. So, what is remaining is 48 into 2 by 5. When you calculate that, it becomes 19.2 ohms. For that 19.2, this 40.8 is in series. Therefore, R total of the circuit is 40.8 plus 19.2, that is 60 ohms. You know the resistance of the circuit. You also know that the voltage available, potential difference 30 volts, you know both V and I, V and R, that implies I can use a formula V equal to IR. V is 30, I have to calculate, R is 60, total resistance of the circuit. So, I equal to 30 by 60, that is 1 by 2, that is 0.5 amperes. That is the reading of the ammeter, 0.5 amperes. You shall not worry about this 20 ohms, because that is a small resistance and that is a part of the ammeter, right. So, if you draw the diagram again, it is 40.8, this is an ammeter. The effective resistance of that ammeter is actually 60 ohms. It is connected to 30 volts. From here a current I starts, that I will go in series and comes back. So, that is an equivalent circuit, that is why the current is 0.5 amperes. That is how we solve the first problem. Let us now solve the other problem that is given for us here. A wire of resistance 12 ohms per meter, ohms meter inverse means resistance per meter is given for you in the problem. Resistance per meter is given for you as 12 ohms per meter, is bent in the form of a complete circle as shown in this diagram. The resistance between diametrically opposite points A and B. So, if I have to draw an equivalent circuit between the points A and B, there is upper part of the wire who has some resistance, there is lower part of the wire who has the identical resistance because both the parts are identical, and these two are obviously parallel to each other, right. So, when they are in parallel to each other, we can write 1 by R parallel equal to 1 by R1 plus 1 by R2 because both are same. I have written 1 by R only, that is 2 by R. So, R parallel equal to R by 2, that is the answer for the problem. R. Okay, let us calculate what is that R is resistance of the each half the circular. R means what are you trying to calculate is resistance of this upper half. How can you calculate the resistance of that upper half? I can write here length of upper half is pi r because that is semicircle, half the circle. So, the resistance of upper half is length multiplied by resistance per meter, that has pi r meter, each meter has 12 ohms. So, the total resistance will become pi r into 12, that is a total resistance, right. Now, pi, that radius is given for you as 10 centimeters. I have to convert them into meters, 10 into 10 power minus 2 into 12. So, that becomes how much? Pi 10 into 10 power minus 2 is 10 power minus 1 into 12. So, that becomes 1.2 times of pi, that is the resistance of upper half. Now, that upper half, this is the point A, this is the point B, this upper half has a resistance R, that is 1.2 pi. The lower half is also identical, that also will have the same resistance of 1.2 pi. Between these 2 points, this upper half is in parallel to the lower point, like I have said. So, when the resistors are in parallel, effective resistance is this 1 by R parallel equal to, as both are same, it became 2 by R. So, R parallel equal to R by 2, that implies resistance between A and B is R parallel equal to any one resistance by 2. Any one resistance we have already calculated as 1.2 by 1.2 times of pi. So, 1.2 pi by 2, that is 0.6 times of pi. So, the answer for the problem is 0.6 pi. That is how we solve that problem, right. Thank you for watching.